No, maybe it was up on my kid too.
It's not my screen.
Yeah. No, not when you was asking me to start with that now, too. Yeah. Yo, Thursday, bro. Before I knew y'all, but I used to be so mad. Well, yeah, I used to piss people off in this fucking Thursday, bro. You play the quarter, nigga. You know, you about to call it out, you get so mad. Hey, you already know who that is.
What's up? What's up? What's up? You already know it's your boy Shadow. OP in the building. Finishing up some stuffed crust pizza. Still a kid at heart. Still my favorite kind of pizza. Let's get into it. So, let's see. We're gonna share screen. Oh, before I do that, let me show y'all where the game at. Might as well just share entire screen. Save us some trouble. Hopefully I didn't just mess that up. I did. All right. All right, cool. Move that out the way. Do me a favor. Well, finish my crust. Don't judge me. I'm fat. Go for it and see if you can see the screen share. No, it's still just showing me. Go all the way. There we go. All right. Thank you. So sound working, screen properly, all the things. I'm gonna boot it up. I want to show y'all the game is actually working the way that we would like right now. All right. Go to the boundaries as far as we want. High as the boundary allows. All right, now the running. I'm having trouble with the running for a little bit because the screen couldn't keep up based on my scroll step. But now we don't have a problem with running no more. Right. The last thing. Let's see this. There we go. The last thing we found ourselves having a problem with. I wonder the collisions for the run are still probably the same as the character. Yeah, that actually worked really good. So the character sprites still have the same collisions. That's beautiful. All right. And then next thing we added was the jump. Hopefully y'all like that. I could hold jumping is basically pogo. but he can't jump again whenever he's in the air. I think I'm gonna make it a way where if you double tap, then you can jump and climb type situation. I think that'd be the easiest way to handle that. But yeah, and then you can also run and jump. I don't really like that though. I almost feel like we should slow down the frame a little bit, just so you can see all of the. But it's happening very like extremely well. All right, so by request, the next thing that was supposed to be added to the game was I wasn't necessarily going to. I was going to put more of the environment in. Um, collision points that had like triggers and put us in the portals. But I'm gonna be watching some YouTube in the background, so that whenever I get to the part where I'm actually doing the code for it, I'm familiar with the enemy code. Y'all can listen to it, and I'll give credit where credit is due. As the videos change, I'm just gonna be watching like enemy UI videos. As the videos change, I'll tell you who they're by. This one is this one's Tech with Tim.
So if you haven't seen already, I have a GitHub for this series where I post all the images and all the tutorial files. Started at 3 just because the first 2 were basic.
All right, so
if you scroll all the way down to the bottom.
First bad guy we're gonna do is like the main bad guy, honestly.
Scroll all the way down to the bottom. These are all the tutorial files.
Let's see, his armor's made from the giant snakes. I need to be careful because I gotta correlate the great snake. I feel like she should be like white and silver, but because he's evil,
We're gonna drag all these images. So like from the top here, all the way down to R9.
His could be more gray. Like there should be a resemblance between him and the great snake. I like my shirt.
And then you're gonna be able to do this. So make sure you do that. If you want to use the sprite,
there should be a resemblance between him and the great snake because his armor is made from the shedding of the great snake's husk.
For example, we have 11 images for our enemy moving left and moving right. So I've done like L10E, L11E.
Let's start like this.
All right, so that's the GitHub. If you guys haven't been there, go check it out if you need to. And yeah, okay. So let's get right into this tutorial. So our game here. Remember from last time?
All right,
now,
we gotta start somewhere. And we're not using a reference on this one. I'm just gonna use my brain.
So we get into our
So
remember from last time we have our little guy jumps up and down, moves around the screen. Now we're gonna create the enemy. So the first thing we need to do when we want to create the enemy is, oops, I accidentally closed this game again. Is we need to create a class so that we can then work under that class. So I've already done this. I've done a class and then enemy, and it inherits from object. And then I've created 2 class attributes. Don't have to worry about what that means. Just write variables that look like this in your class. Now, I've already loaded up all the images. So I have R1E, R2E, all the way up to R11E and L11E into their names here. So walk right, walk left. And you just do that at the top of your class. And then after that, you can define your initialization function. So now you don't have to understand exactly how these class attributes work. Just write them in like this and we'll get to them later. So we're just going to create our initialization here. So we need x, y, width, height. And then we're going to create another one here that's new. It's going to be called end. And I'm going to go over that in a second. So do self.x equals x, self.y equals y. Wow, I can't type. And self.width equals width. And so on until we finish all of the variables, and then we'll add our constants, self and equals So now we're going to add our self.walk count. This is what's going to be responsible for counting our sprites and what image we're on. And then we need self.val, and that's going to be equal to, we'll start with 3. So now we need to create our draw function, our method, sorry. We're going to define draw. Inside here, we're going to take self in the window. And then we're just going to write pass in here, so we're going to get back to that. And then we're going to create another method called move. And then here we're going to do self. And that's all we need, just self in there. All right, so I know I've just whizzed through that. It's just because we went through this a bunch of times. So I figured we can move fast through this part. What we're going to do here is we're going to create our enemy. Now, our enemy is going to move on a set path. So like I showed you before, it moves from left to right, and then left, and then right, and pretty much moves between 2 coordinate points. So ours is going to move in one dimension, meaning it's only going to move across the x-axis. Now, if you wanted to move this up or down, you would just change the y value rather than changing the x value. Okay? Whereas for us, since we're making x, we're just going to be adding to the x value or subtracting to the x value depending on where our enemy is. So I want to run this program already. I have another file where it's already coded. You can see once he gets to a coordinate point, so what we're on, he turns around, he changes directions. Now, to change directions, it needs to change velocities. So to do that, we're going to be multiplying the velocity by -1 and so on. And I'm going to get into that now. So this is going to be our move method here. Now, what this move method is going to be responsible for is every time we try to draw the character, we're going to move. So we're going to do self.move in here, so we don't forget. Every time we draw, we're going to first move, and then we're going to draw the character. Now, I just need to add another variable here. It's going to be called self.path. It's going to equal self.x and self.n. Now, this represents where we're starting and where we're ending. And these are just the x coordinates so that we can keep track of them when I'm checking them down in the move method. So we go into the move method here, and we're going to start by saying if our character has a velocity that's positive, so pretty much if self.velocity is greater than 0, that means we are moving right. So we're adding to the velocity. Then what do we have to do? Well, we have to check if he is about to move past the point that we want it to stop at. So we're going to do if self.x is greater than, or actually, we're going to check if it's less than, so we know if it's less than, and then self.path. And since we're moving to the right, we know this coordinate is going to be to the right of whatever, our character is moving at. If it is less than, self.path. And then from there, we just do one like this because we're accessing this element here. So we're having break right there, minus self.velocity, or plus actually. So this way, we can tell, so we need to change this to here, plus self.velocity, so that we see that if we add to the velocity of this x coordinate here, if it's less than the coordinate that we can't pass, then we will allow our character to move. So then we'll do the self.x plus equals self.velocity. I hope that makes sense. Now, if we are already past this coordinate, so our x is greater than, or we are about to be greater than, then we need to change directions. So to change directions, like I mentioned before, we're just going to multiply our velocity by -1. Therefore flipping us 180 degrees and moving us in the opposite direction. Then what we're going to do is we're going to set our walk counter back down to 0, like that. And that's all for that. Now, we need to create our else statement because if our velocity is negative, so it's not greater than 0, then we need to check if our self.x is minus the self.velocity this time is greater than, in this instance, what's going to be self.path 1, like this. Or not 1, 0, sorry. So this is exactly where we started from. We're moving negative, so we want to make sure we don't go past that. If we're not moving past that again, we'll change our x. So do self.x plus equals self.vel. Now you might think, well, we should be subtracting if we're moving left, but our velocity is going to be negative if we've changed directions to move left. So if you're adding a negative, you're really just subtracting that number, so that's fine. And then same thing in the else statement here. We're just going to copy exactly what we have here. Oops. Don't know why I deleted it. like that. So we have self.bell is self.bell times -1. Again, changing the directions to negatives being positive, we're going to be moving right again, and self.walk. So we can get rid of this pass, and that's all we need for our move method, like that. Alright, so now after we've done that, we're going to move back into our draw here. And this is where we're going to determine whether we're drawing an image to the left or whether we're drawing an image to the right, and how the animation is going to work. Similar to what we've done in the player class up here, it's going to be a little bit different. So if you remember in our player class, so actually let's go up here for a second, we have 27 as our maximum walk. Now once that walk has been past 27, we reset it back down to 0, so we can continue the animation. Now since we have 11 images actually, rather than 9 in our enemy, so moving right, we need to change this slightly. So we're going to do if self.walk count is less or plus 1 is less than or equal to 33, like this. Then we're just going to do self.walk count equals 0. Sorry, my typing is absolutely horrible. Now, if that's not the case, or after we check that, then again we're going to be checking to see whether we're moving left or right. So rather than having like a self.right variable, a self.left variable, or attribute, whatever, we want to just use the velocity, because we know if our velocity is positive, we're moving right, if our velocity is negative. So if our velocity is greater than 0, that means we're moving right. So if it's greater than 0, all we're going to do is we're going to blitz the screen, the images again. And so win.blitz, and then we want our image, so we're going to do self. And this is where these come in handy. You just have to use self to access these. All right, so we're going to use self.walk right, so we're moving right. And then in here, square brackets and self.walk count. And then integer division 3. Again, because we want to make sure it's not looking like we're moving too fast. Then we need our coordinates, so we'll do self.x and self.y. And then we need to increment the walk count, so we'll do walk count plus equals 1 like that. Now else, so if we're not moving left, we have 11 images actually, rather than 9 in our enemy, so moving right around. We need to change this slightly. So we're going to do if self.walk count is less or plus 1 is less than or equal to 33, like this. Then we're going to do self.walk count. Wow. Equals 0. Sorry, my typing is absolutely horrible. Now, if that's not the case, or after we check that, then again we're going to be checking to see whether we're moving left or right. So rather than having like a self.right variable, a self.left variable, or attribute, whatever, we want to just use the velocity, because we know if our velocity is positive, we're moving right. If our velocity is negative, we're moving left, right? So if our velocity is greater than 0, that means we're moving right. So if it's greater than 0, all we're going to do is we're going to blitz the screen, the images again. And so win.blitz, and then we want our image, so we're going to do self. And this is where these come in handy. You just have to use self to access these. All right, so we're going to do self.walk right, so we're moving right. And then in here, square brackets and self.walk count. And then integer division 3. Again, because we want to make sure it's not looking like we're moving too fast. Then we need our coordinates, so we'll do self.x and self.y. And then we need to increment our walk count, so we'll do walk count plus equals 1 like that. Now else, so if we're not moving left, or if we're not moving right, we must be moving left. I'm just going to copy this, and then we can put it in here. So we're just going to change this simply to left. And I think that's all we need to do. So now that, I'll actually get rid of this pass here. Now that we've had the draw method, we have the move method, what we need to do is we need to create an instance of our enemy. So right now, if I show you to run the program, since we haven't created an instance, he's not on the screen, we don't see him, he's not moving around. We need to first create the instance of it. So just like we created the man instance down here in our main loop, we're going to do the same thing. I'm just going to call this Goblin. And he is an instance of enemy. He's going to start at, what I scored, maybe 100, 410 again, and then go to 64 by 64. And where do we want it to end? So what X coordinate at the top do we want it to end at? Let's make view 450, and there we go. We create an instance of it. Now the instance we need to draw. So goblin.draw on the window, and let's test this. Name that is not the fun error that I've ran into here. We need to just put some thumbnail here. My bad. And let's see if it works now. Walk count, reference book your number. So just make sure you guys have yourself here because I forgot them. And implementing it properly. Or this is the issue. Less needs to be less than 33, which it always is 0, so it wasn't changing ever. So what we needed to do there is we needed to set this to greater than. So that, sorry, guys, my mistake there.
Right.
Let's run
Great
this.
time, right?
And there we go. We see our goblin.
Now you're asking me.
And when he gets to the end coordinate, it changes direction. So he has a nice little
There you go.
in there.
Okay.
So what we're going to do with this in the next photo is going to do collision with our player. So if he hits the player, it's going to look for points, and then our player gets his bullets, right? If he hits the goblin, buttons start flashing, some game points. You figure that out in the next photo. So sorry about a little issue there, guys, but if you enjoyed the video, please leave a like and subscribe, and I will see you in the next Hey guys, and welcome back to another YouTube video. So in today's video, I'm doing the game programming series, and in this video, we're going to be talking about collision. So specifically collision between the bullets and our goblin that we did in the last tutorial. So you can see here when we have our little character, you can shoot his bullets, our goblin runs around the screen, and I've got these little red boxes around my characters here. Now, they look very oversized, but currently this is actually what our characters' hitboxes look like. Now, to do collision, we typically use boxes in Pygame just because it's easier. You can use trigonometry if you're doing stuff with circular objects, but we're just going to ignore that for now because it's a lot easier to do with squares. Now, the way that the hitbox works is pretty much as soon as these two boxes come in collision with each other, so one is inside of the other, we're going to say that the two objects are colliding. Now, clearly, these hitboxes are not perfect, and they are not correctly around our characters. They should be shrunken in a little bit and probably move down so that they're touching each edge of our character. Because I go to the edge of the screen here, remember we've said that our character X, which is here, plus the width, if that's going to be past the edge of the screen, we're not going to let it move. And same thing on the left-hand side here. It's not going to be quite perfect, but you can see that the same thing goes for here. It's not letting us move off the screen like that. So that is indeed our hitbox. And the reason it's so big is because the images that we downloaded are 64 by 64, but the actual populated areas of pixels is not that much. So we have to now create the hitboxes for these characters so that when we are shooting our bullets at the character, they collide properly. I'm also going to show you guys how to fix these bullets from shooting at like the same time. You can see how they shoot two at once. It's a pretty easy fix, and I'll do the state for that. Okay, so let's get right into it. So in order to fix these hitboxes, we just need to manually define them. So this is what a lot of game developers will actually do, and I know it seems tedious right now, but it's easy because it's easy to do. It's better to do now, actually, because once you do it, then any instance of the class you create later will have a hitbox that's a. So I'm just going to open up on my other screen here. You guys can't see it. The perfect like dimensions for the hitboxes, just so we don't have to play around with it too much. But if you have a different character, a different sprite you've used, You're just going to want to play around with the hitbox on it, maybe move it left to right, move it up and down until it looks like it's about on your character. So what I'm going to do here, I'm just going to copy and paste this in my player class up here in the first initialization method. I'm just going to do self.hitbox, and then I'm going to set it equal to this. So it's going to be, make sure you have the brackets, not the square brackets. We're going to do self.x plus 20, self.y, 28, and 60. Now you might notice, so whenever you have 4 things inside of a tuple, typically we just refer to that as a rectangle, because this is going to be the x, this is the y, and this is. Now conveniently, this is actually the argument that our draw function, or what do you call it, function, draw method takes for drawing something on the screen. So we've created a rectangle here, but inside of this box, I'm just going to write self.hitbox. So now it's going to be drawing our new hit. Now for a move, right? So if we just define hitbox is not going to be moving with our player, so we're going to copy this again, and we're going to need to paste it at the bottom of our draw method here. So this way, every time we draw the character, we're going to be moving the hitbox with it and changing that hitbox so that we can check for it. And you'll understand what I mean in a little bit if you don't get it now. So we're going to go down to the enemy now. And for the enemy, the hitbox is slightly different, but it's pretty similar. So I'm just going to do self.hitbox again as an attribute. And in our initialization method, we're just going to paste it and just copy this down. So self.x plus 20, self.y, 28, and 60. Now that is what it is for our enemy. And same thing, every time we move our enemy, we need to change it. So at the bottom of our draw, we're going to change the hitbox simply by doing that. Now, again, we need to find this new hitbox. So in our draw that we've done here, we're going to just write self.hitbox. And the reason we don't need to put brackets around it is because we already have the brackets here. We're going to save the program and run it and see what happens. And there we go, we get our hitboxes. Now you can probably tell that they're not perfect. I could probably play around with them a bit more to make them better. I'm going to fix this guy actually right now, just because his hitbox is a little bit off. The goblin, it's fine for right now. I'm not going to worry about it that much. So let's go back up to the player character here, and this is what I mean. Once you create the hitbox, you're going to have to play around with it a bit, just to make sure everything's perfect. So we'll go here, and we're going to change this to 17, and we're going to change this self.y, we're going to add 11 to it, we're going to change this to 9, and we'll change this to 52. And these are the numbers I was looking for. We're going to change these ones a little bit too. So for our self.enemy, or just for our enemy, what am I saying? We're going to be using 17. So let's change this one first. 17, self.y. We're going to add 2 to that. We're going to change this to 31 width. We're going to change the height to 57. Then you can go ahead and copy that, paste that up here where our other hitbox is defined, and we're going to run the program one more time and see how that looks. And that looks much better. There we go. So the hitboxes now are, I'm going to call this one hit, and the argument or parameter. Then we're just going to pass it. Now this is what you guys are going to do every time that the goblin gets hit. So for me, I'm actually just going to print hit. You guys can do whatever you want in here once the goblin gets hit. That's all I'm going to do for right now. Okay, so now that we've done that, we need to check for collision. So the way we're going to check for collision is in our main loop here. And we're pretty much just going to check every time the bullet is shot, so not shot, but like if a bullet is moving across the screen, that's why we have this for loop for all the bullets. In this for loop, we're going to check if the bullet has collided with the goblin. Now, to do this, there's a few if statements and else statements we need to include. Now, it's a little bit complex, but pretty much, if we run the program, a good way to understand it is always like drawing and visualizing stuff in programming, is when we shoot the bullet, we need to see if it is inside of this rectangle. Now, if it's inside of the rectangle, then we're going to say it hit. If it's not inside of the rectangle, then it didn't hit, right? So if we jump up here, although the x's might be the same as the x's here, we need to make sure that it's inside the rectangle, so it has to be in between the two y values of our square. And that'll make sense to explain this here. So before we start moving the bullets, what we're going to do is we're going to do an if statement here. We're just going to check if the bullets are within the same y coordinate, so within the top and the bottom of the rectangle of the ball.
So I'm just going back
So
to
if the y coordinate of our bullet is in between the
Oh,
top
wow.
and the
Okay.
bottom of our rectangle, then that means that the y coordinate of our bullet, which is in the middle of our bullet, which is an issue, so we need to add, or we need to actually subtract the radius here, so that we are checking the bottom of the, or the top of the bullet. If that is less than our goblin hitbox, so dot hitbox, and we're going to use the y coordinate of the hitbox here plus the goblin dot hitbox, and this is going to be our, what do you call it, our height, so goblin dot hitbox of 3. So this means if we are less than, if we are above the bottom of our rectangle, and now we need to check if we are below the top of our rectangle, so now bullet dot y plus bullet dot radius. So this means the top of our bullet, or the bottom of our bullet, sorry, is less than or greater than, and now we do goblin dot hitbox, and just the y coordinate here. So now this part here, this checks to make sure that we are above the bottom of the rectangle of our goblin, and this part here checks to make sure that we are below the top of the rectangle. Now, just because we meet those two criteria does not mean we've hit the goblin. So to see if we hit the goblin, we now need to check the left side and the right side to make sure we are in between that. So to do that, similarly, we're going to do with bullet.x, so instead of y, minus the radius, or plus bullet.radius, what am I doing? And here we're going to need to make sure we have bullet so that this works. Can't just put radius like I've been putting there. Bullet.radius. So plus the bullet.radius, if this is greater than the goblin.hitbox x coordinate. So hitbox 0, this axis is our x coordinate. This means that we are on the right side of the left side of the rectangle. Hope that makes sense there. And our bullet.x minus our bullet.radius is, what is it here? We're going to have to make sure that it is less than the right side. So to do that, we then need to do goblin dot hitbox 0, sorry, because we're accessing the x, plus goblin dot hitbox 3, or hitbox 2, because that's going to be the width. All right, and that should hopefully work. So now, if that is all good, so that means that we've satisfied all these conditions now, then that means we have to do something. So if we are within the y coordinates, we are within the x coordinates, then we just have to do the hit, right? So we're going to do goblin.hit. And this is what happens when the goblin gets hit. It's going to come up here, it's going to call this, and it's going to print hit. Now we also want to make sure that when we hit the goblin, our bullet disappears. So to do that, we're going to do the same thing that we did here when we were moving the bullets. And we're simply going to remove the bullet from the list. Now, we already did this and how it works, but it just removes it from the list. And we can go ahead now and run the program, and hopefully everything should be working. All right, so we've got our two little characters with their hitbox, and when I shoot my bullets and they hit the goblin, you can see that it says hit. Now, yes, sometimes they hit at different points. So sometimes you can see they disappear instantly. Other times they take longer. They go further into the box. That's fine. They're still hitting. Now, the last error that we need to address here, the last thing, is the fact that our bullets shoot in like groups of 2 and groups of 3. Now, it's actually a pretty easy fix. So just follow along right here. We're going to need to create a variable to do this, and I'm just going to call this shoot loop. You can call it whatever you want. I know shoot loop's kind of a weird name, but that's what we're going to use. And at the end of our, when we're shooting the bullets here, so when we hit space, I'm just going to do shoot loop equals 1. Now I'm going to come back up here, and I'm just going to write a little bit of stuff here, and I'll explain how it works after. So we have if shoot loop is greater than 0, then shoot loop plus equals 1. And then if shoot loop is greater than 3, shoot loop equals 0. And then I'm going to come down here, and I'm going to say, and shoot loop equals 0. Okay, so I went fast there, but pretty much what happens here, and this just fixes our issue by setting like a really basic timer, is we say we're only going to allow the user to shoot a bullet if the bullet cooldown is met. So the bullet cooldown is what we're going to be calling shoot loop pretty much. So when we first shoot a bullet, we have shoot loop equals 1. Then we run through the while loop, we go through the rest of it. We come back up to the top, we say if shoot loop is greater than 0, meaning that it is 1 or greater. Then we're spamming the spacebar. It's not working because our shoot loop is not equal to 0 yet. Then we're going to go through the while loop again. It's going to become 3. Is shoot loop greater than 3? No, it's not. We're going to go through it again. And then eventually, once it becomes 4, we're going to set this equal to 0. This is now going to be met, and it's going to allow us to hit space. Don't really worry if you don't understand how that works. Pretty much it's just setting a really basic few milliseconds to make sure that we can't just. Anyways, let's see if this works. And now you can see that was weird. So that it kind of gives like a spam this big, so that it kind of gives like a break between bullets. And yeah, and we also have that limit, so you can only have a screen at a time, and that's also just to reduce lag. Everything seems to be working pretty well. Now, in the next video, we'll go on to make sure to make this player collide with the goblin. If you guys feel so, feel here, you might want to try to do this by yourself, so you can see if you can get a player to hit the goblin.
Birds, you know, hear them?
But not really, not that much. And if you guys want anything else too, try to see if you can add a score variable that says how many times the goblin gets. Pretty straightforward. If you guys enjoyed the video, please leave a like and subscribe to the channel. If you have any questions or concerns, leave a comment down below and I'll person would want to make. So I'm just going to do it like this, and then hopefully you guys can learn from this, and we'll be able to make your own games in the future. So let's ready. So we're just going to make a variable at the top of our program.
Come on. I'm trying to go to the bottom of my computer and blanket so I don't overheat. I'm good. Let me reword that. Chest sight. Armor made from giant. Just a giant.